I'm not going to lose any sleep.
Okay. No, but teacher, what do you think?
I think many things. It's up to you. Your choice. I don't think it matters too much, to be honest.
Yeah.
I was only offering to you in case you wanted to. But I mean,
Have you done it already? Have you prepared it, teacher?
no, I usually do things at the last minute.
Okay, then it's okay then. Thank you, teacher. Thank you for offering.
Yeah. Offer still stands any time though. It's not like it's gone or anything.
Yeah.
Okay, we'll continue. Why were you absent yesterday?
I was sick.
Okay.
Okay.
Right. Come on, Batman. We'll start. Okay, so we're looking at tangents and normals. Look, come on. I'm tired. It's 4 o'clock. I just want to get home, okay? Just give me a break, please. We'll just make this easy, okay?
Yeah, sure.
Right, great. Okay, so tangents and normals is what we're looking at. Now, what's wrong? I think it's okay. Yeah, I think we can see okay. So, we all know what a tangent is. Yeah. But does anybody know what a normal is? Nothing to do with the second derivative, actually.
90 degrees to the tangent.
That's it, yeah. I don't know if I mentioned the word normal before in parallel and perpendicular, did I? Yeah. Anyways, even if I did, here it is again. So this line here, we call a tangent. And this one here, which is perpendicular, we call a normal then. So you want to write that vocabulary down, please. What we're concerned with today is finding the equation of the tangent and normal. What's wrong?
I smell orange.
What?
I smell like orange.
Maybe it's my lollipop, I don't know. No, this is like a blackcurrant or something. Coke flavour perhaps, yeah. Alright, did you draw that?
1 second.
Yes.
Yeah.
1 second.
I'm missing Haza and
Hazard.
yeah, and
Just as that.
yeah.
This hazard.
Okay. Right. You got that? Yes? Okay, so let's have a look at a simple enough example. So maybe the type of question you might get in the exam would be something like this. Find the equation of the tangent to the curve. Let's see, we'll keep it simple, we'll just make it a quadratic. Y equals x squared plus x plus 1 at the point, we'll say x equals 1. So we'll keep everything nice and simple then. So a rough sketch means we're looking for this tangent line here, okay? So if we're looking for a line, we're really looking for two pieces of information, aren't we? We're looking for an M and a C. Right. So the first thing we can get is the M. How can we get the M? What is it, do you think? No, because it's quadratic, not linear. Yeah.
So white minus.
No, because we only have derivative. Yeah. Derivative.
Why did you use x plus c?
Because tangent is tangent line, so it's a line. Yeah. What is it? 2x plus 1, and x is equal to 1, isn't it? So this is 3. Now that we have the m, all that's left to do is to figure out what the c is. And how can we do that? So what?
Just one
One.
Any point.
It's one.
What?
Yeah, so what's the point we're subbing in?
No.
No.
Derivative? 3?
Sub the x equals to 1 into the first equation.
I think we do second derivative.
I think some of you have it. We have to sub in a point, normally. And our point is 1, 3.
Why?
Now, how did I get the 3?
Subdivision.
Into which one?
The main.
This one here. Sub x equals 1 into that.
1, 1. Yes.
Yeah? And then with this, sub it in there. Let's see, yeah. 3. Yeah. C is 0. So the answer is just y equals 3x. That's the tangent line. So interestingly, this tangent line passes through the origin. Okay. That's a typical exam question. Very typical. You can write that down. Matar, I think you have your jumper on upside down. It's a new style?
No.
Yeah.
It's a old style.
Old school. Huh? All right, have you got that written down? Yeah. So, I'll change it a little bit. I'll have you try this one. The only difference I'm going to make, and I want you to try this for me, it's just I'm going to change tangent to normal. So, what step is slightly different? Which step in this process? Yeah. What will it? Yeah, exactly. Because it's perpendicular, the m gets changed to what? Minus 1 over 3. So see if you can get the equation. The c should be different as well now. Yeah. So see if you can get that equation. Try this one now.
So what is the m?
You tell me what's m.
I mean, just now.
No.
Huh.
What was the m?
This is 3.
And if change it to what? Yeah.
Huh?
Because.
I didn't get it.
Hang on. Because. Why are we changing it to minus 1 over 3?
Because it's
Perpendicular.
Yeah. Yeah.
perpendicular.
Yeah.
Negative 1 over 3.
Yeah. Yeah. Yeah.
Yes.
So give it a try.
Ah, okay.
M1, M2.
It's the same question.
Yes.
Yeah, I'm just changing the word tangent to normal. Finished? Just give you one more minute and then we'll have a look at the answer. Yeah. So,
1 second.
okay. Okay. Have some of you got an answer? Yeah? So can you see the only difference really was at this step where because it's perpendicular it's minus 1 over 3 x plus c. And when we sub this in now the c is not 0 anymore, is it? We have 3 equals minus 1 over 3 plus c. So what's that? 10 over 3?
Yeah.
10 over 3. So now the normal is y equals minus 1 over 3x plus 10 over 3. Now, I don't need to calculate this, but if I asked you the question, where do these two lines meet, you could work that out, but we know already where it should be. What point? Where do these two meet?
1, 3.
1 and 3. Yeah? It's the only point they meet because you got a tangent at 1, 3 and a normal at 1, 3. So, if you were to make this a simultaneous problem, you'll find the solution should be 1, 3. Yeah? Okay. Now, I'll give you one a little bit harder, but still the same idea. I want the tangent line to y equals ex when x is equal to 0. Yeah. So another one now. Try this one. First derivative is needed, yeah? Yeah? Got it? What did you get?
This.
Yeah, I think the equation, the line.
I
Mx plus C. Get an answer?
No. I'll just get this.
Okay. Come on, guys, I thought you'd get this. It's not too difficult.
Y equals to e over x.
It is not. It's not. It's not. Yeah. EX, yeah. No, no, no. EX. Did you get it? What you get?
Oh, this is your math files? So you take all this? Are you serious? Oh.
Okay, let's have a look at this. Guys, we'll have a look at it now. I'm a bit surprised I didn't get more right answers, but let's have a look at it now. Now, guys, we're having a look at it. Guys, we're having a look at it now, okay?
But you never
No, we're looking at it now, come on. So, the m is what? dy dx. And what's dy dx here? Ex still. And what's the x? 0. So this is 1. So this is y equals 1x plus c. And what's the point here? X is 0 and y is 1. So if I sub that in, I'll get 1 equals 0 plus c. So c is 1. So you finish off by saying y equals 1x plus 1. Okay, so that's the answer. As quick and as simple as that. Now write that down if you don't have it. Which should be half of you, I think. So please copy this down. Okay, have you got that?
1 second.
I better give you one more to practice before we go on to something else, just to make sure you've got this. So, We'll do another tangent. Well, no, we'll make it a normal this time. Can I scroll down?
1 second.
Okay. I think we're just waiting for you, is it? You have it? So, find the normal to y equals 1 over x at x equals 1. There you go. Try this one now. Okay, you got that? What you get for this? Y equals x, I think. Yeah, it should just be this. So m equals dy dx, which equals minus 1 over x squared. X is 1, so this equals minus 1.
Yeah.
But that's for the tangent. We want the normal, so it's actually 1. So y equals 1x plus c, and the point we're subbing in is x equals 1 and y equals 1. By using that formula we can see the y. So if we sub in 1, 1 into here, we'll get 1 equals 1 plus c, which is then 0, and we are left with y equals x then for that. Okay, so copy that down, but I think most of you got this one now. You wrote that down? Yeah. Okay, so let's go back to tangent, but an application of tangent. Can I scroll down? Okay, let me draw a rough graph for you. If you can copy this graph down to x, y, and then we'll make the function y equals root x. Okay? And let's say I'll mark off the point here. Yeah, let's keep the numbers easy as well. We'll mark off the point 4. So if I'm at x is 4, what's the y? 2. Why? Square root of 4. Yeah? Okay, I want to show you the one thing that's useful about tangent. So I'll just give you a minute again. Give me the tangent line at 2, 4 here. Okay, so it should only take you 1 minute. Go calculate that, please, tangent line. Oh, sorry, I said 2, 4. At 4, 2. Yeah, tangent line at 4, 2. Okay, did you get the tangent line? So again, m equals dy dx, which in this case will be a half x power minus a half, isn't it? And the x is 4, so is that a quarter? Yeah. And then we have y equals a quarter x plus c, so we sub in our 2, so is c 1? We got c as 1? Yeah. So we have the tangent as y is a quarter x plus 1. Now, is that right? Are you sure? Something feels wrong.
It's right.
Oh no, it is right. Yeah, okay, yeah. Right. Now, I said I'll show you what is so useful about tangent lines. If you were to look at this graph, let me zoom in a little bit. Now, it's not perfect, but it meets here at one point. As you move further away from this axis 4, can you see how the distance between the tangent line and the curve grow? It increases distance. But what's interesting is if you're close to 4, then the distance between the two is not much. They're kind of similar in height. So this means that the value of y you get for the tangent line and the value for y from the curve should be close to each other, as long as you're near 4 in this picture. So what I'm saying, if I just write that down to be clear, I'm saying that the square root of x, which is the curve, that should roughly equal quarter x plus 1, as long as x is near 4. Now this is actually useful because you can use tangent lines to simplify calculations. You can get rough answers, you know. So for example, if I said something like, what is, I don't know, the square root of 4.1, if you didn't have a calculator? Well, by using this formula, is 4.1 near 4?
Yeah.
Yeah, so this should be roughly equal to 4. Don't use the... Put it down. Put the calculator down. We're pretending we don't have a calculator for a moment, and then we'll check how good our estimate is. So it should be 4.1 over 4 plus 1.
Why 4? Ah, okay.
Yeah? Which is equal to 1.025. That's 4.1 divided by 4, isn't it? Plus 1. That's equal to 2.025. Okay. So I'm saying the square root of 4.1 is roughly equal to 2.025. Now check on your calculator. What is the square root of 4.1?
2.0248456.
Yeah, so it's pretty close. You said it was 248.
It is.
Yep.
248.
Yeah. Okay.
Because
I just picked 4.1 as an example, as a number near 4. Okay, so this is why tangents are useful, because they can simplify calculations. Okay, because otherwise calculating the square root of 4.1, I think none of you would know how to do this without a calculator.
Yes.
Yeah, I thought so. Okay, so I want you to do something similar, again, like what I did here. I want you to find a tangent line, and the reason I want you to find the tangent line is to get a rough answer to a second problem I have. So let's choose something like what will we use? Not square root. Something that's hard for you to calculate. Maybe like log. Yeah.
no.
I don't think it matters so much. Y equals log x. Here's the graph of log x. Okay. Now I need to log what point will I use here? Okay, I'll just use no, I'll use 2. I'll just use 2. And I want you to get a tangent line. And the reason I want you to get the tangent line is because I want you to get an estimate of log 2.1. And you're trying not to use your calculator, so if you're not using your calculator, I have to tell you the value of log 2, because you'll need that in the calculation later. It's roughly equal to, I think, 0.69. Well, let's double check it. What is it? Is it roughly 0.69? 0.31. Okay. Right, without using your calculator, by using tangent lines, I want an estimate of log 2.1. And the only thing I'm giving you to help you in your work is I'm telling you what log of 2 is. Okay, try this now. I'll do it in a moment. Just like my example on the left.
In the exam, we won't use calculator.
No, you can use the calculator, but you'll need to show your work. So I just want you to practice now without the calculator.
Okay. Just time, I guess.
Oh well, actually, I can see another calculation you'll have trouble with later because you'll need to calculate 1 over something. No, actually, you know how to calculate 1 over 2. No, Dash, you put the phone down. What are you looking for? You can't. 1 over x. Put the calculator down. We don't need it yet. Yeah.
I just times.
Huh?
I just times.
It's not that difficult without a calculator, is it? Is it?
I got 1.1791.
How do you get the line without a computer?
Yeah. Nice.
He understands it. It's good. No, you see this? This is correct. Then you put the log 2 inside here. Take it out.
You got an answer? Is this because you don't have a calculator?
Yes.
Yeah.
It's like decreasing our self.
4?
But teacher, can we use the calculator to find out what's the y?
Yeah. The y? No, you know the y. I gave you a hint.
What hint? Y equivalent in x?
Yeah.
No.
Ah,
Oh, I didn't know.
Oh, it's right there. Okay,
yeah,
okay.
right in front of your
there,
face.
Right
Yeah.
there. It's right there. Ah, okay.
discovering Einstein's theory here, okay? You're doing some arithmetic.
Teacher, 2 more minutes.
What? You want to look at the example on the left, is it?
Wait, 1 second.
You have it? Huh? Is that the look? Right, once I get back to the board now, I'll have a look at it.
No. Sabrina. Sabrina.
Close to this number. Because 2.1 is close to 2. So 1 to 2.2 can be different. 2.2 is wrong to 2. So you're right in there.
Cross check.
Yes, can I double check my work?
Right.
Yes, I got it.
Wait.
Is it 0.7431?
What is it?
0.7431?
Did you use your calculator?
No.
Are you sure?
Okay.
Okay, fine. That sounds reasonable. Let's have a look. Come on. Right. So, first let's get the m, which is dy dx, which is 1 over x. And then the x is 2, so it's a half, 0.5. Fine. So we have y, 1 over 2 or whatever, a half, 0.5 x plus c. Now the point here is 2.6931. So you have to sub that in to get the c. So that's 0.6931, isn't it? And then 0.5 times 2, which is 1 plus c. So the c would be 1 minus 0.6931, isn't it?
No, it's 0.6931 minus 1.
Becomes minus.
It's minus the other way around.
Oh, okay, well, I'll fix the sign later, yeah. So the c, this is negative c.
Yeah.
Fine. So, well, this is an easier subtraction to do. So that's 9, and that becomes 10, but that becomes 9, that becomes 9, 10. That's a 0, sorry. So 9603, 0.306.
Yes.
Okay, so
Yay.
congratulations on subtraction. Your elementary school teacher will be proud. I don't have any stickers to give you. Right. So minus 0.3069. And so our tangent line, we have log x is roughly equal to 0.5 x, minus 0.3069. Now, we said x is 2.1.
Yep.
So this will, log 2.1 is roughly equal to 0.5 times 2.1 minus 0.3069. So that's roughly equal to 1, no, I got this, 1.05. 0 minus 0.3069. That becomes a 4, a 9, a 1, 1, 3, 4, 7. So 0.7431. Now, what I would like to know is, what is the log of 2.1? How close are we to the true answer? 7419. Grand. Okay, so we are correct to the first two for sure, and we're not too different. 3.1 and 1.9 in the further decimal places isn't too far away. Okay, so this is an example. This method here is what you would call a linear approximation. What you're doing is you are replacing something which is not linear with something that is linear. Okay? It's a very standard technique for simplifying problems. You see this a lot in science, in like physics and chemistry and biology. Sometimes you can just make a linear approximation because your values don't differ too much from some particular value that perhaps you know. Like if you take, for example, like body temperature or, something like this that's kind of a fixed point, and you want to know what happens when you slightly increase or decrease it, you can probably make a linear approximation. Okay, but I think Colin will talk more about this if he hasn't already with the graphs. Has he mentioned anything about linear approximations? No? In your graphs?
Not yet.
It's
Not
like
yet?
we just finished discussing about.
I'll give you an example, like in biology. If you have some exponential graph like this, but you're only looking at values which are maybe here on the x-axis, then you could make a linear approximation. Now, it won't be perfect as soon as you start going outside of this range, but if you're confined to this range, then it's a reasonable approximation. Yeah. Okay, I'll give you just 3 questions to do. Five, six, seven. 5, 6, 7.
Thank you.
Right, get started now. Yeah, you should get them finished. It'll only take you a minute. 5, 6, 7. There you go.